Okay? Awesome. We'll get started here. My name is Dallin Warne. Thank you for coming here. I'm here to answer a question and support that answer here. If you want to follow along, on your own device, look up the QR code here or go to the link. I'm going to have that up for just a moment longer. I find that it's helpful to be able to follow along on your own device instead of taking a picture every time the slide changes or something. So you can follow along there or just right on the screen. I'm getting over a cold, and so there's still some side effects there. I don't think I'll lose my voice again at this point, but if I need to pause for a moment, you'll know why. Thankfully, I have some water up here and stuff. So a little bit about me. My background is in networking. I started out at Network Operations Center, moved over to network engineering, and did some network security there, and ended up going to doing security engineering for the 3 BYU schools, one here in Provo and then Hawaii and Idaho as well, and that's where I am currently. So I've been doing, at least in the networking area, for several years, and then in the last few years just focusing more on the cybersecurity side of things. But that's a little bit about me, but I wanted to also get a feel for the people here in the audience here. Just by show of hands, how many, just going through the industries of what we have here, how many of you are in healthcare, the healthcare industry? Oh, quite a few up here and some in the back. What about education? Yeah, I'm in the education, of course. Government? Any in government? A couple. Retail? Not much in retail. Finance? Tech? Do we have any? Yeah, a lot in tech. Any others that I missed that you guys want to give a shout out to your industry for? Okay, so we have a fair amount of diversity here from the different industries. Now, how many of you have some form of network security monitoring, whether it's a firewall or an intrusion detection system? How many have some type of network security? Okay, that a show of hands is pretty good there. If you don't, we'll talk a little bit about it here. Now, how many of you don't really focus on your network security because of encryption? It's just not a priority because it's like, well, why? I see a few of these out there. Encryption it's really changed networking in general, but network security especially, and cybersecurity. I know it's everywhere. It's expected. If your company isn't doing it, then people start to wonder, is your company really putting my data am I putting my data in safe hands with this company? Other reasons why it's everywhere, the cost of enabling security or SSL, it's just dropped a lot in the last 5 years especially, because you have Let's Encrypt that you can literally get a certificate for free now. You have them championing protocols like the Acme or different bots that'll automatically renew those certificates, so you don't have to worry about them. So it's easier to implement. 20 years ago, there was some concern about, well, encryption will hit our CPU, and it might slow down our servers and stuff. That's really not the case today. There's a lot of improvements and strides that have happened there. And so we can see that trend over the last few years of just the adoption of SSL on websites, right? So this is just a time graph of Chrome. And just showing, at least in the United States, 4 years ago, we were about 45% of pages were loaded over SSL, and now it's 92% as of a couple weeks ago. 92% is a lot these days. So it's with network security, it's looking pretty bleak, right? And it raises the question with a lot of security teams, a lot of organizations of, do I invest in network security at this point with 92% of these pages being loaded over HTTPS? What value does it really give me at this point? So is network security monitoring dead? And it is dead. So that's it, guys. No, okay. No, it's not dead. I'm big Simpsons fans. Any other Simpsons fans in here? Please? All right, nice, yeah. Quantum computing might, at least dramatically change or kill it. But today, in this day and age, we're actually still, network security monitoring is still going pretty strong. Now, don't get me wrong, encryption does reduce visibility, and it does affect it, but it doesn't eliminate it. And it forces security teams to evolve how they're doing that monitoring of their network. Now, I wanted to touch on 5 reasons why it's not dead. We're going to hit reason number 1 pretty hard and a little bit more in depth, because if we don't, then the other reasons don't make quite as much sense. But the first reason is not everything is encrypted or is going to be encrypted in the near future. And you can still find really good value of that data here. So why isn't everything encrypted yet, or will be in the next year or two? Well, you still have a lot. There's a few main things. You have legacy devices, legacy apps. You have shadow IT, and you have one-offs on your network, right? You have that server that was just built for this one purpose, one thing that. Or it just doesn't quite fit with everything else. It was special for whatever reason, and so you get just a variety of things that makes it difficult to turn on SSL everywhere, right? Going back to that legacy apps and stuff, your company might have bought some very expensive equipment. If it's in medicine, it might be a dozen MRI machines, and you only have a budget every 15 years for those or something. In university setting, we see a lot of like astronomy equipment or physics equipment that it was bought in the 90s, and the apps were made for Windows 95 or older, and the university's not willing to spend, or they can't get grant money to spend $50 million for another piece of equipment, right? And so those persist. A few other reasons, a little bit more in the technical areas, there's still areas that are hard to adequately actually do it right, the encryption. SMB is a good example. Syslog, most of your Syslog stuff is UDP, and you send it to port 514 on some Syslog server somewhere, right? Often there's not any options for doing some type of encryption there, and if there is, it's not guaranteed your syslog receiver is going to be able to support it either. Another couple of reasons, you might have a low return on investment. You might put in a lot of work to encrypt that traffic, but does it really lower your risk much? Look at if you have a web server and a database server, and they're both in racks in the same row in your data center, and they're locked and stuff. Does it really? What value does it really bring to keep that traffic in the back end encrypted? Or you might have performance sits. Tor is a privacy advocate's dream, right? Layer upon layer of encryption, and one node not knowing much about the other. But then you try and use it, and you're only getting like 56K, right? It's not usable for most purposes. Or your IT or sysadmin just wants to get an app working or service working, and they just don't think about the security side of things. So yeah, 92% of that US traffic, web traffic, is encrypted, but 8% can still be a lot. If you have a 10 gig ISP link, assuming it's saturated with web traffic, that's still 800 megs per second that's unencrypted. That's still quite a bit. Or if it might be 400 if you have a 5 gig link. And web traffic is not all that security professionals, security analysts care about. SMB is always talked about, and everyone needs to have their eyes on it. And often it might not be encrypted in a lot of environments. And DNS is a big one as well. You also have the headers of some of these layer 4 conversations and stuff. Also, you're not going to encrypt your MAC address or your IP addresses and stuff. So this is a kind of a breakdown by protocol of an enterprise environment. And you can see again, SSL is basically like a Pac-Man eating up everything else, right, on this pie chart. Yes, it is dominant. You still have a few of those other protocols. You still see a little bit HTTP traffic, but let's see what happens. Instead of measuring by bytes, what if we measured by session count? DNS explodes, right? Now I know UDP is not session-based, but for stateful firewalls and security monitoring, we kind of count it that way. So you have a ton of DNS traffic out there that's immensely valuable to your security analysts. And so let's dive in a little bit deeper on DNS here. What value does it bring to a SOC? What value does it bring to an organization to be monitoring your network for DNS traffic? Well, first of all, you can grab a lot of good stats and performance monitoring. I'll tell you right now, a lot of the top queries I've seen in these environments I've worked in were due to either misconfigured servers or devices, bad software, or they decommissioned some server that helps manage some of these endpoints and stuff, but the endpoints, they still trying to call home to that old server. Great place for security analysts to investigate a little bit, because if those things are outdated, then it's likely there's other security vulnerabilities there, right? Not to mention your network team loves it when you give them some information that helps improve their performance. You can find machines that are not using your approved DNS servers. A big one is just any new domains or malicious domains. You can identify those with your network security monitoring. DJ domains and tunneling and stuff, those have been hitting the headlines for the last couple of years on malware and threat actors that are doing that. And I investigated a phishing incident a few months ago where the phishing domain was registered 6 minutes before the first emails were sent out. So I mean, new domains or known phishing or malware domains are still valuable and huge for your security analysts. One of the ways that you can implement some protection mechanisms on DNS is through DNS sinkholing. Basically, you have maybe a list of known bad domains. They're tied to different malware families or something, and you have some type of security device, often a firewall or IPS, that will basically man in the middle those DNS requests when they see them. And instead of responding with the actual IP of that bad server, it responds to a benign server that probably you control or someone controls. And so now now when that client here, make sure that pops up. Now when that client tries to make a HTTP or HTTPS request, it's going to hit your Sinkhole server, and you can look at what it's actually trying to hit, the actual domain. Like in this example here. On the right, we see a couple domains that were sinkholed. The IPS decided they're probably not very good. And so we've stood up a web server there so that a connection could be made and that request to a server can be made so that our monitoring can pick it up. Now we can go back to the system owner and say, hey, look, it looks like you have this type of malware on here based on these DNS requests it's making and trying to reach out to. Now I want to pause here just for a moment. Throughout this part of the presentation, I talk about general principles, but to me it's helpful when I can tie them down to earth to actual practical applications, things that I can do when I return to work after the conference and stuff. And so I focus on a couple more well-known tools, Palo Alto Network Firewalls and Zeek, or formerly Bro. These are tools. There's other tools available. Each one I feel has their pros and cons. I just happen to pick these because these are a little bit more popular. Here's a good DNS tunneling example of what your monitoring can do. On the right, it's supposed to be DNS queries, and I don't know about you, I don't think any of those really look right. You can, with your security monitoring, you can measure the entropy of those DNS requests. You can look at abnormalities in those queries, and that's a really good flag that you might have some type of tunneling or data exfiltration on your network going on. Just for reference here, the entropy of what's considered high is about a 3.5, and these are in the high 4s to 5 range, so not normal at all. Just a couple more examples here. Feel free to look at them on your screen if you're following along on your device. We already talked about some different DNS protections that Palo Alto can give from sinkholing. In their new version 9.0, they have the additional DNS security capabilities to kind of shut that down. And Zeek has some basically the same capabilities. Can give you a little bit more insight though. Now I just want to note just real quick on DNS, yeah, there's a lot of conversations going on about DNS over HTTPS right now, right? I just want to touch that. There is, some controversy, but it looks like for the most part you can maintain DNS visibility in your network. I'm not going to go too much into depth. There's a session later this week that will go more into depth on that. I'll let them, you can ask your questions and stuff there. Now, another example, let's look at SSL and TLS itself. What value can your SOC get from that? Well, often clients, whether it's the actual web browser or maybe it's their email client or something, they're going to try and hit the domain first over HTTP very often, and then the servers will redirect them, right, if they do support HTTPS. So you can find often what URLs are actually trying to hit. And then a lot of the tools these days have some type of metadata analysis. For example, the SNI. This is how Palo Alto Networks does their URL logging for HTTPS sessions. Is they look at the SNI, or the server name indicator that the client requests. And in TLS 1.3, there's some movement to get that encrypted along with the other pieces of the handshake. It's kind of complex. It's just a flip of a switch. And so, watch the adoption rate. It's not going to happen very quickly, at least in the next year or two, or maybe in your next purchase cycle, probably won't. So, watch that. There's probably going to be some ways to either downgrade those types of requests, or you might even be able to block it in your DNS servers. So that they're still forced, your clients are still forced to send that unencrypted SNI there. Certificate information is also a gold mine for threat intelligence. You can profile what websites, again, are hosting certain certificates. JA3 hashes. Anyone know what JA3 is in here? It's pretty new. Salesforce has been piloting or pushing this. Basically, you take a hash of the client handshake and the server handshake, and you compare those hashes against known malware fingerprints, because malware being automated, they tend to do the same things in the same way, right? So they're going to reach out to their command and control servers the same way, and the command and control servers are going to respond in the same way. So that's another way of an indicator of compromise, is looking at the JA3 hashes. And then there's other organizations looking at encrypted analytics. Cisco's pioneering that. So it's not like we're completely blind when something is wrapped in SSL. There's still some ways to get some good data out of that. Here's an example of the Palo Alto Botnet report, just a few lines. I've anonymized the data. The domains are from known emotet command and control domains. But it's an example of Palo Alto using that unencrypted SNI to generate reports and to give analysts data of what might be compromised. This is an example of the Zeek SSL log. This is also valuable for engineers and analysts. If you want to know if you have any SSL3 on your network, you think you don't, but you need to confirm it. Well, you can write queries against the version field and see, oh yeah, we do or we don't, or what server is hosting it or not. We have the JA3 hashes that I was mentioning here. If your organization is supposed to be using a standard certificate authority, you can also check that as well in these Zeek logs here. I've already kind of briefly touched on these, so I'm going to move on to kind of the final section of reason number 1 before we move on to the other reasons. So let's say, if everything else is encrypted, layer 7 is all encrypted and stuff, what value or currently can you still get from it? Well, MAC addresses are still pretty valuable. You have companies that do a lot of profiling of IoT and of just endpoints in general, and MAC addresses play into that, along with other behavior characteristics. VLANs can help security analysts identify if conversations between networks, whether they should be happening or not. IP addresses, as much as we might do all these behavior analytics and fancy threat intelligence and stuff, there's always going to be some type of IP list, either to block or to consider suspicious. Your IP is probably not going to be unencrypted anytime soon, or encrypted anytime soon. Geolocation is also good on that. It's not perfect, but if you can put in, if you don't have any business with Iran, go ahead and put in your firewall to block or at least limit what Iran can hit on your network, right? A couple other things, if all else fails, I'm not a big fan of NetFlow data for security incident response, but if you're investigating a breach or something, any data to help paint a picture is helpful. Because if you have a database server that was breached, it has a 200 gig database on there, but you only see 1 meg of traffic leaving the network. That is a good indicator that data was probably kept safe. Either they only got a sample of it or they didn't take it all, right? And then there's a lot of research as well into IP-based patterns. So, maybe for persistence, some malware dropped or set up a cron job or a scheduled task, and that's running every 5 minutes or 15 minutes or every periodically. There's some ways that you can look for that type of behavior. I did forget to mention, if you guys have any questions, raise your hand. Feel free to kind of interrupt me as I go along here. So tool analysis, just on your basic layer 3, layer 4 type of connections. You still got, again, you get a lot of that data in these different types of logs. You can protect your network in this way. I did put on the SSH log for Zeek, because even though it's completely, it's SSH, it's encrypted, you can still pull metrics or information out of that, even getting pretty good guesses on whether a connection was successfully authenticated or not. Excuse me. So all right, so that was reason 1. Again, we went in depth a little bit, because now you get the feeling that, yes, there's a lot of unencrypted data on the wire that can still provide me and the SOC a lot of good value there. That's not, we only touched on a few points. There's plenty of others that you can get some good insights out of. And yeah, those were just a few. So reason number 2, the network itself needs protecting, right? Because there's still like DDoS attacks out there. There's still other ways to manipulate packets or just cause things to go a little weird and stuff. So you got to properly segment your network. I mean, I know that's probably been the advice for the last, at least for the last 5 years and probably longer. You also have the DDoS protection or DOS protection, resource protection, recon protection that comes with your Palo Alto firewalls that you can turn on and tune. And also look at your outbound traffic. If you have workstations that are compromised, sending out thousands of spam emails every few seconds or something, you're going to end up on block lists. And you don't want to deal with the users calling in saying, "Hey, why can't I access these websites that I could 10 minutes ago, and I need to do them for my job." So watch that outbound traffic as well. Reason number 3, inventorying and profiling. So every cybersecurity framework, they list some type of inventorying or identifying what's on your enterprise. That's like the first step. just in everything, NIST, SIS, whatever it might be. And to really get a good picture of what's on your network, you need network security monitoring out there. You know, you might have a pretty good deployment of endpoint agents, or you know, tracking your assets that way, maybe physically. But you got the shadow IT. If you have the centralized IT, you're bound to miss something. You got just things on your network that you just won't know about if you just rely solely on one source. So you need to combine those sources together to paint a picture of what's on your network. And you can't adequately, you know, protect what's on your network unless you know what's there. It's just, or not only what's there, but where it is as well. A good example of where this came in handy recently, there's been two new DDoS amplification attacks that have been discovered in the last year or so. One was Memcache several months ago. And then just in the last couple months was WS Discovery. And so what we could do is we just went to our log monitoring solution and plugged in the ports and our address range and stuff, and you know, did a quick query, and it returned all the results of what has those ports open to the internet that are being taken advantage of and participating in these DDoS attacks. They all happen to be IoT, and we can't put endpoint protection on those IoT devices. There would have been no way. We would have had no idea if we didn't have network security monitoring that we were participating in DDoS attacks against other organizations. Another good reason is network security monitoring is device and application agnostic. So it doesn't matter if it's a login form on your SSO or login form on a webcam. Your network security monitoring can, the protections and the logs that they generate are the same. You can normalize those events. So if you have an F5 and an Nginx and IAIS and Apache all in your network, they're all producing logs in different formats, or the fields are a little bit strange or weird or something, or it's unstructured. Your network security monitoring, you deploy once, and it doesn't matter what software is running on the end of, you know, those endpoints and stuff, your data is going to come back consistent, pretty much every time. And it really simplifies, you know, instead of trying to pull from 20 different systems that your organization uses, you just kind of need to rely on one. And yeah, you need to do a little bit of fine tuning there, but for the most part, again, the protections and the login stuff is consistent and the same. And then shadow IT, you know, your guests and stuff, that's pretty much the only way you have. When you don't have access to the endpoint itself to do any type of protections there, what do you have left? You have network monitoring, basically. So then reason number 5, auditing and forensics. You might think, oh yeah, we don't have any SMB open to the internet, or yeah, Telnet is completely out of our network. You know, maybe your tools are reporting that, but again, you have a lot of IoT you don't really know about that might be on your network, and your network security monitoring is going to be the only thing that can give you a clear, big overview picture of, you know, of that traffic there. So you can find misconfigurations and poor performance. You know, again, we're going back to the DNS query example. If you have, you know, 10,000 requests every few seconds from a server, you're not going to know that from your endpoint solution. You will find that out through your network security monitoring, or, you know, DNS monitoring or something. You don't think you have SMB open to the internet? I can't tell you how many times I thought we didn't have something open to the internet, and then we find there's some convoluted way, either like a proxy or you know, some hole that was punched to the firewall that allowed it through. And so it goes, you can confirm, you know, that traffic. Yes, you do, or yes, you don't have that certain type of traffic on your network. And forensics is a great use case for network security monitoring as well. You know, if once a machine is compromised, the trust in the data coming out of that machine drops significantly. Logs might be erased. They might have a zero-day exploit that they're doing to hide their tracks that your endpoint solution isn't watching. So it provides a second layer of confirmation or trust of what's going on. And again, if you're doing incident response, you'll want anything that you can get. It's completely independent, and that's why it makes it such a good auditor or such a good tool, is because no matter how many workstations are compromised, your network data is not really going to lie. So some modern network security strategies. I mentioned this one before. You got to properly segment your network. You really need to invest the time to separate your sensitive areas from your not so sensitive areas. Your workstations from your servers. There's just needs to be some access controls and proper network segmentation going on there. And once you're doing that, then it makes east-west monitoring a lot easier. Because if they've bypassed your firewall, well, now if they want to traverse different segments, they're going to have to keep bypassing that, and it makes you more likely to be able to detect when there's some type of security event going on. Another strategy is to span behind where your SSL terminates. So if you have a load balancer or a proxy where your incoming web traffic terminates, well, between that proxy and your actual web servers, the pool of servers, you can tap there or span there, and you can still pull in a lot of the application layer information and data, and still receive a lot of those protections. Another more growing in popularity is decryption. It's still, we'll talk a little bit about that one in a minute, but it's very useful and can be a little tricky to implement. Another strategy is to centralize. So on the left here, we have a picture of Fort Knox. I had the largest repository of gold at one point. You have layers upon layers of security. You have very thick walls, it looks like, guard towers, fencing. There's probably like hidden bunkers or something in there. And then we have your local bank branches. There's about 800 or maybe 1,000 bank branches scattered throughout Utah. That doesn't look like there's too many armed guards out there or guard towers or something. But we know Fort Knox, as far as we know, was never robbed. Maybe it was, and it's been classified and sealed, who knows. But for the most part, it's not like it happened every day. In 2018 alone, there were 40 bank robberies in Utah. It illustrates that when you can fortify together, when you can band together your IT, your resources, your organization, and have a consistent and fortified IT infrastructure, you're a lot less likely to be compromised. I mean, eventually, you're always going to be compromised at some point, but it makes it a lot more easier to detect, or first to protect, but then to detect and respond and shut it down before any major damage is done. Whereas if you have decentralized IT, or you're just not cooperating with, you have the little different segments in your IT and stuff, you're bound to either miss breaches, or if you do find them, it's not going to look pretty good. So if you can centralize and consolidate, standardize on security hardened images, it makes things a lot easier for both your SOC and for your IT teams. So a little bit about decryption. So as much as we can get that data that's not encrypted, just on the wire, kind of what we have talked about, to really do good network security monitoring, you do need that application layer. You need that visibility into there. And really the final way that you can get it is through decryption. Most of the time it's just limited to SSL or TLS, so you're not going to go to your vendors and say, hey, I want to decrypt the SMB traffic on my network that we do have encrypted, if we do. They just don't really, it's not really a big feature request. And so most of their attention is doing SSL and TLS decryption. So in the past, traditionally, your certificates were managed by your operating system. Several years ago, your browsers started to have their own certificate store, and now we see apps as well. They're doing some type of certificate pinning or these other protocols where if the app excuse me, doesn't recognize the certificate that it's expecting from the server, then it's not going to do it. It's not going to complete the handshake and send the data. And so you're starting to get more of these complexities here, where one place will support that decryption, based on those certificates and stuff, whereas other places in the apps won't. So there's going to be a lot of trial and error. It's not trivial. You're going to have to kind of take this, baby steps at a time if this is the strategy that you want to take. And before you really dive deep into trying to do decryption, you got to figure out certificate management first. If you're doing inbound inspection and you have 100 or 1,000 certificates on 1,000 different servers, it's going to make it really difficult. If you at least have some proxy points, you can get a lot more visibility, a lot more mileage there. But if you really want broad decryption and broad visibility, you're going to have to figure out that certificate management piece. You also got to remember that you're also re-exposing sensitive data, because now your login form to your CAS login or SSO is encrypted, but now you're decrypting it, so now those passwords and those credentials are coming across in clear text. You got to see how you're going to handle that, and how are you going to handle some of these sensitive data, and decide what you're not going to decrypt as well. And then once you have a tool that does, a lot of these tools now support forwarding on that decrypted traffic for additional analysis, whether it's out of band or in band. And take advantage of that. Take advantage of your layered security. Send that decrypted traffic for, if your firewall decrypts it, send it over to your IDS as well. And so you can get that broad visibility there. And finally, just don't expect 100% decryption. There's some things that you're just going to have to accept that you can't decrypt. Let that phone app worry about their own security, basically, right? Some additional trends that we're seeing with network security is there's a lot of offload going on in two different ways. One is isolating things you just don't have any control or very good visibility into. Great example are your guest networks, right? You have guests coming on. There's really, you can't provide, they're all untrusted. You can't really provide good protections against yourself against them. So, you segment them off and kind of treat them as their own little space, right? There's a lot of IoT networks that companies have created. Another big one is just moving to SaaS. Organizations let's not deal with the headache of running this type of system. PCI is a good example. There's products now where the company will sell these point-of-sale devices that you can plug into any untrusted network. They take care of all the PCI compliance within the device itself. That takes a whole burden off the organization, right? And that's just one way that you offload your risk. Send it off to someone else to worry about. Other trends is integrating your network data with the other data points. We've been seeing that with SIMs for several years now. Centralize your logging, send all your logs to this one place, and then try and figure out alerts or other queries to correlate that data together. More recently, we've been seeing vendors that are trying to provide a suite of solutions, from the endpoint to the network to the cloud to application security. They feel like a unified approach and an integrated approach is especially helpful in defending against attacks. But we have also seen in the last couple of years emergence of these big data security analytic platforms, whether it's user behavior analytics or just other types of analytics on your security data. Again, these are just examples to give you kind of a flavor here. They're not anything I'm endorsing or anything. But Palo Alto's Cortex XDR solution, or Google's child company Chronicle, their backstory platform, they've been putting a lot of effort and a pretty good solution there from just the propaganda that I read. And so you see this integration of your network data with everything else so you can paint a picture of what's going on. The other thing that we've seen is moving from a kind of this high confidence approach. You used to see a log that said, yep, here's your usernames and passwords flying off out of your network, exfiltrated. Now we see some suspicious or abnormal activity going on with this endpoint. Let's go check it out a little bit more and figure out what might be going on. So we see a little bit of that shift as well. And then I do want to end on this last piece that I am a network security person, but I also understand and recognize that network security is just one piece to a holistic security program. Excuse me. You need multiple sources, multiple areas that require cybersecurity principles and visibility into. Network security is just one. We know about endpoint security and cloud security and others, and when you can combine them together, that's what makes them, all the more powerful and all the more effective. So I encourage you, keep in mind your network security program, but don't forget everything else, and don't think it's standalone. We got to come together. So with that, that's the end of what I have prepared here. I hope you guys can take back this knowledge with you to your organizations and kind of evaluate, if we are going to continue our, what we're going to do with network security monitoring, and hopefully it can give you some points that you can take back and look at what you can apply in your own network. So with that, that's it. If you have any questions out there for me. Yeah, go ahead.
What's your experience with network security monitoring in the cloud?
So the question was, what is my experience with network security monitoring in the cloud? I have very little. We do have a couple of my coworkers do network security monitoring up there, and we've been watching what the vendors are doing up there. Azure and Amazon are offering. They're pretty new for Amazon, but basically these virtual taps in your network. So Azure's had it for a while, where you can kind of tap that network traffic. Amazon just recently announced that, I think earlier this year, the capability of doing that. There's still some questions there. I mean, if you're using Amazon's SSL, private key store and stuff, there's not a clear way of how you can decrypt your traffic coming in. There's still some unanswered questions there. So it's still being pioneered, and it's an area where the cloud providers acknowledge that, it's still a little difficult to do. I wish I could give you a better answer. I want a better answer. Any other questions? All right, great. Well, thank you guys very much. I appreciate it.